Okay, welcome back. This is the review for exam 3. This is covering some of the questions on the review that was sent out. That's on Canvas. So find that if you haven't already. But I'll be talking about some of those problems. So let's talk about number 3 to start. Well, we've got a straight river flowing east. At 6 miles an hour. And then we have a woman launches a boat from the south shore. So she's starting, say, here. And she wants to land at the point directly opposite the shore. So she wants to go here, but if she just aims directly at it, of course, the river's going to push her downstream. So she needs to really angle her boat in this direction, somewhere over there, right? So that the sum of her boat moving through the water and the boat moving, or excuse me, the water moving her boat sums up to a northern direction with no east or west component, right? And then the question is, what angle should she move her boat, right? So we can express a couple of things here. We have the velocity of the boat. Since it's going east, I'm going to call east a positive x direction. It's going 6 miles per hour east and 0 miles per hour north or west. So that's the velocity of the boat. Oh, no, it's not. That's the velocity of the water. Sorry. So we've got the water's velocity, and then I've got the velocity of the boat, which I don't particularly know right now, but its vector is going to be something. I'll just call it x and y to start. I don't know what it is, but I do know in the problem, if I keep reading, the speed of the boat relative to the water is 12 miles per hour, right? So I do know that this is 12 multiplied by the cosine of that angle that I'm looking for times the sine of the angle that I'm looking for, right? And what I really want is these two to add up to give me 0 in the x direction. That is to say, I want 6 plus x to equal 0, right? But x is 12 cosine theta, so that is to say that I want 6 plus 12 cosine theta to equal 0, right? And if I subtract 6 from both sides, I get 12 cosine theta equals negative 6. Divide each side by 12. I need some space here, so I'm going to erase this. But this boils down to the cosine of theta should be equal to negative 1/2, right? So you should be able to know where that happens. Cosine of theta being negative 1/2 happens at 2 pi thirds. Right? And so that tells me that this x comma y should be 12 cosine 2 pi thirds comma 12 sine 2 pi thirds, which of course 12 cosine 2 pi thirds is negative 1/2. I'm going to erase this one more time. I'm sorry, I wish I had a humongous board to work on, but I don't. And so this is negative 1/2, and then 12 sine of 2 pi thirds is just 12 multiplied by root 3 over 2, and so that is 6 root 3. Right? And that makes it work. I'm sorry, this is not minus 1/2, it's minus 1/2 of 12, which is negative 6. Right? And therefore, my angle is 2 pi thirds, right? And that's an acceptable answer. In the answer sheet for the review that I gave you, which I didn't write, so it covers some stuff in language that we may not have talked about. But if you think about where 2 pi thirds is, 2 pi thirds is somewhere over here, and in between 2 pi thirds and this straight up and down 90 degree, there's an angle of 30 degrees in between those two. And this is north. If this is east, then this is west, right? So what it really is 30 degrees west of north, and in bearings, which you'll see in airplanes and ships and things like that, they'll write it as look north, but then turn 30 degrees to the west. And so that's the same thing. But if you're taking my test and you write 2 pi thirds, that's what I'm looking for, right? If you want to go be a sea captain, that's what you're looking for. Okay, let's look at number 4. Number 4 says find the angle, and there's a bunch of questions like this. So I'll do this one, find the angle between these two vectors, and then I'll skip it through the rest in the sake of time, but it's all the same kind of process. So it says find the angle between vector W, which is -3 I plus root 3j, and V, which is root 3I and plus or minus 3j. Okay? So you need to know this formula, and that is to say that we have the cosine of theta. In this case, in terms of W and V, the vectors would be W dotted with V divided by the magnitude of W, which is then multiplied by the magnitude of V. Right. So I want to find this product on the right here. The dot product is, again, just the x components multiplied, so -3 times root 3 gives me -3 root 3. And then I add on the dot product of the others, which is going to be negative, so minus another 3 root 3. So that's just the dot product. In the end, that's going to be a minus 6 root 3. Over the magnitudes. The magnitude of W is the square root of 3 squared plus square root of 3 squared. And then V is going to end up being the same value because they have a root 3 here and a 3 there. So it's still 3 squared plus root 3 squared, right? But this is 9 plus 3, so that's 12. So I have root 12 multiplied by a root 12. And so in the denominator here, I just have a 12. Okay? Get that over just, there we go. All right. So I have that, and then that means that my cosine theta equals, if I simplify this 6 and 12, that turns into negative root 3 over 2. So, and, of course, that happens at 5 pi 6. And that's it. We're done. So again, anytime it says find cosine theta is just leaving it in this format here. If you ask to find theta, then you actually take the cosine inverse to find theta itself. Right? That was 4. Let's look at 6. And again, I'm skipping 5 because it's essentially the same idea. 6. Oh yeah, 6 talks about some stuff that we didn't discuss in this class. So I'll explain it here, but no, you don't need to know how to calculate a force. You don't need to know how to work with force and distance to figure out work. That'll be Physics 1010. But, 101. But we've got constant force is of 3 root 3, and then it moves along, so this moves an object from 0, 1 in a straight line straight to the point root 3 and 4. Then they want you to find the distance as a vector. So that is to say, I've got this object, and the fact that it's being moved by a force doesn't matter here. I'm moving from a particular point to another point, right? I can consider this a vector where this is my terminal B, this is my A, and so the vector AB is what he's calling the vector D in this case, which is simply the x component of the end, right? So root 3 minus the x component of the beginning, so that's root 3 minus 0, comma, the y component of the end point minus the y component of the initial point, right? It's the same way that we found vectors initially. Okay? So that is to say that my distance, my movement of this is root 3, comma 3. That's the movement as a vector. Now the part that we didn't use this language for this problem, but we still did stuff like this problem. The part that we didn't do is we never talked about a dot product in terms of force and distance, right? And resulting in work. So the equation here is simply that work is the dot product of a force over a distance, right? And this force is a vector, the distance is a vector. So really all he's saying in this problem is figure out the force, which is given to us as a vector, dotted with the distance, which we now have as a vector. And so that's all it is this 3, comma root 3, the force, dotted with the distance, root 3, comma 3. So that's 3 root 3 plus another 3 root 3, which is 6 root 3. And then the last question, we've talked about this. It says find the angle. Oh, it says find the cosine of the angle between the force and the distance. So that is to say cosine of the angle, which is the force dotted with the distance, which we just did, so that's 6 root 3. I'm going to steal that from above, over their magnitudes. And these are the same, they're going to have the same magnitude because they're essentially the same numbers, a 3 and a root 3. And so it's going to be the square root, and we saw this. 3 squared is 9, plus 3 more is 12. And so I'm going to get a 12 under a root times another 12 under a root. And so I get this. We're looking for the cosine. In fact, this turns, it looks like basically into almost number 4. Right. Except here the cosine is positive, so this is simply, if you wanted to figure out the angle, that's what, pi over 6, right? Alright, but enough of that. You don't need to know that work is force times distance. That's physics. We'll get to that when you get it. Well, not we. You'll get to that if you take a physics class. You'll probably see it if you hit a calculus class as well. They're going to introduce it there, but not terribly important for us. Okay. What was that? 6. Let's look at 7. So for 7, we're given 2 vectors. U is 2 root 3, comma 2, and vector V is -1 root 3. Okay? And so we're first looking for in A, we're looking for 3U minus 2v. Okay. And so u is, I'm just going to replace these, so this is 3 times 2 root 3, comma 2, minus 2, and replace v with negative 1 root 3. Distribute these through, so that becomes 6 root 3, comma 6, minus, and I'm going to take the minus in there with it, so this becomes plus, negative 2 times negative 1 is a 2, negative 2 times root 3 is negative 2 root 3. It's a goofy looking 2. And then I just add component wise. 6 root 3 plus 2, comma, 6 minus 2 root 3. And that's my resultant vector. For B, it says find u dotted with v. So that is to say 2 root 3, comma 2, dotted with negative 1 root 3. Again, we multiply component-wise and then add together, so that's 2 root 3 times negative 1 is negative 2 root 3, plus 2 root 3. And therefore, that's 0. And I'm going to leave this here for a second, and let's do C over here. C says find the magnitude of u and the magnitude of v. So magnitude of u is the square root of 2 root 3 squared plus 2 squared. So 2 root 3 squared, be careful with this, you're going to square the 2 to get a 4, you're going to square the root of 3 to get a 3, 4 times 3 is 12, 2 squared is 4, so that's the square root of 16, and so the magnitude of u is 4. Right. Whereas the magnitude of v is the square root of negative 1 squared plus root 3 squared. So that's 1 plus 3, and so that is root 4, and so that is 2. Okay. And then D says if theta is the angle between u and v, find cosine of theta. And so I left this up here because I can steal all of my previous answers here. But I have cosine theta is u dotted with v over the magnitude of u times the magnitude of v. And I can steal all this because I have u dotted with v is here is 0. The magnitude of u is 4, and the magnitude of v is 2. It all doesn't matter though because this is all 0 because of that 0 right there. So cosine of theta is 0. And if cosine of theta is 0, E says find theta. Well, the inverse here, cosine inverse of 0, that's pi halves or 90 degrees, whichever you want to call it. Okay. Let's look at 9a. 9a says complete the square and then describe whether it's an ellipse, a parabola, a hyperbola, or a degenerate. And we'll talk about that on D. But for A, I've got x squared plus 6x plus 12y plus 9 equals 0. And so my x's are already kind of next to each other. So this x squared plus 6x to complete the square here. Half of 6 is 3, square it is 9. So instead of adding 9 and then subtracting 9, I'm just going to steal this 9. Because it's already there. right? And so if I can factor this, well, I can factor this. I designed it to be factorable down to x plus 3 squared. I'm going to shove my 12y off to the other side. Something tells me that was squared when I was looking at it earlier. It is not, though. All right. So this is then equal to negative 12y, right? And you should be able to recognize this as a parabola. My x is squared, my y is not, right? This gives you, I can't remember if they call it a or p in the book, but it's, 4p or 4a, whatever it is. But in this case, a is negative 3, right? And that tells you how far into the parabola that your focus is and how far on the other side your directrix is, right? So they ask you for a couple of things. They ask you for the vertex. The vertex happens at negative 3, and since there's no plus or minus over here, then it's 0. So it's negative 3, 0. Right. The focus. Right. The focus, you move 3 into the area, into the parabola. I don't know what it's called. Into the inside, the interior of the parabola, right? So my vertex here is negative 3, 0. That's 1, 2, 3 right here, right? And since this is an x squared and then a negative y, right? That means this is a facing downward parabola. And so the vertex is, the focus is going to be down. And so I have a focus here that's just 3 down from the vertex, and so it's just at negative 3, negative 3. And the last thing is that the directrix is that line. If my focus is 3 in to the parabola, my directrix is 3 out of the parabola, and so that is the line y equals 3. Let's look at 9D. 9D is, x squared plus 16 equals 4 times y squared plus 2x. So it's not in any sort of form that we'd like it to be in. So I'll start by distributing that 4. This gives me x squared plus 16 equals 4y squared plus 8x. And I'm just going to grab everything and push it to the left, right? It looks like when I do that, I'm going to have a positive x squared and a negative y squared, so I'm probably building